Hey Coach, this is my tutorial 13. We're going to have it so that the servo goes 180 and back, and then this thing changes speed, and these lights turn on and off depending on where it is at. And there you go.
Okay, Coach, here is my breadboard and schematic. So, starting off with our breadboard, we are going to go with our servo motor first. So we have our 3.3 volts going through. Then we have our port 3 going through. And finally, it goes through the servo and down into ground. All right. Now we have our transistor. So we are going to be connected to port 9, then connected to a 100 ohm resistor, then an NPN NPN transistor, and that is going to be connected to our motor, connected with a diode. Goes through the motor, and 5.5 volts goes around, and through the transistor and then it connects back to ground through the transistor. All right, now we have our port 8 and 7, our LEDs. So port 8 goes around through our 100 ohm resistor, then through our LED and out to ground. Then port 7 through our 100 ohm resistor to our red LED and then back to ground. All right, same with our schematic. We'll start off with servo, 3.3 volts. Our port 3 goes through and then back to ground. Our motor, let's start off with it this time, 5.5 volts. Goes through to our transistor. It's connected to our port 9, 100 ohm resistor, NPN transistor, and out to ground. All right, and finally our LEDs goes through our port 7, goes to our 100 ohm resistor, our LED, and back to ground, and our port 8, 100 ohm resistor, green LED, and back to ground. That's it. Thank you, Coach. Okay, here is my code and serial monitor. We have Daniel Beaton, Coach L, Gloucester High School, the date, electrical engineering, experiment 13, code description. We are using a for loop to move the servo back and forth. When the servo is below 60, a red light lights up. When it's in between 60 and 120, all off, and 120 and above is a green light LED. We are also changing the speed of a motor using a method with a for loop inside, and when the motor speed is below 90 degrees, a red LED lights up. When it's in between 90 and 180, all off, and 180 and above is a green LED. Board description. A servo motor is attached to 3.3 volts, port 3, and then connected to ground. Then we have two LEDs on the board connected to ports 7 and 8, then connected to 100 ohm resistors, and finally back to ground. Finally, we have a transistor connected to port 9 and also connected to ground, and connected to a motor that uses a diode and is connected to 5 volts. All right, so so we have this include servo. This is so we can use the servo 1, so that's what it's called, the motor pin, and the LED pins. All right, void setup. We have our serial begin, our setting up our servo, our motor pin and set to output, and our LED set to output. That is the end of the setup. Now our void loop. We have our position variable, then our for loop that is going to count up position by every 2. Then we have our count up, so you know our serial print count up, so we know when it's counting up. Servo write, so it goes to said position, printing out where the position is. And then we have our if position that lights up the LEDs. If position is lower than 60, lights up our LEDs. Else if 60, in between 60 and 120, that is low, making it off. And then our else, which is above 120, which turns our other LED on. Then we have our delay and our end of 4. Then in between, we have our motor acceleration loop, which if we go down here, it is void motor acceleration, begin, and then we have our local variable speed with our delay time. So 4, it goes up to 255, which is the fastest the motor goes. It prints out the speed of the motor, as you can see over here in real time. And then it moves it to said speed, as seen earlier. Here is our servo position counting up and down. Here's our if speed is below 90, turns on our first LED. Else if, in between 90 and 180, both off. And our else above 180, and that is our other LED. In delay time. That's the end of the 4. Then our de-acceleration of the motor, which is 255.20. And that printing out the motor speed, as you can see in a second, right here. It'll count down, moving the motor to said speed. And then we have our in-between 90, turning it on. In between 90 and 180, turning it off, and in between and above 180, it is turning that last one on. And then we have our delay time. That's the end of the method. So then after that, we have our for loop. It goes to position 180, or it starts at position 180 and goes down every 1. So it's count down. Bring it to said position, print out said position, and then if it's below 60, 1 LED is on. If in between 60 and 120, all off. And then our else, if above 120, on. Thank you.